Welcome to a journey through the cosmos, where we will explore the incredible scale of the universe, from the tiniest quarks to the majestic galaxies that fill the night sky. The universe is a vast and complex tapestry, woven from the fabric of matter and energy, and understanding its scale is essential to grasping the nature of reality. At the very foundation of all matter are quarks, the fundamental particles that combine to form protons and neutrons. Quarks are incredibly small, with sizes on the order of 10 to the -18th meters, far beyond the reach of conventional microscopes. There are 6 types of quarks: up, down, charm, strange, top, and bottom. These quarks combine in various ways to form protons and neutrons, which in turn make up the nuclei of atoms. The strong force, mediated by particles called gluons, binds quarks together, creating the stability necessary for matter to exist. Quarks are never found in isolation due to a phenomenon known as confinement. They are always found in groups, such as pairs or triplets, forming composite particles called hadrons. Protons and neutrons are examples of baryons, which are made up of 3 quarks, while mesons are made of a quark and an antiquark. Moving up the scale, we encounter atoms, the building blocks of matter. An atom consists of a nucleus, made up of protons and neutrons, surrounded by a cloud of electrons. The size of an atom is approximately 10 to the -10th power meters, making it about 100,000 times larger than a quark. Atoms are defined by the number of protons in their nucleus, known as the atomic number. For example, hydrogen has 1 proton, while carbon has 6. The arrangement of electrons in various energy levels around the nucleus determines how atoms interact and bond with one another, forming molecules. The chemical properties of elements are governed by quantum mechanics, particularly the principles of wave-particle duality and the uncertainty principle, which dictate the behavior of electrons in atoms. Scaling up further, we reach the realm of biology. Cells, the fundamental units of life, are composed of countless molecules and structures. A typical cell is about 10 to the -6th meters in size, or 1/1,000,000th of a meter. Cells come together to form tissues, organs, and ultimately, entire organisms. The complexity of life arises from the intricate interactions between these cells, governed by the laws of chemistry and physics. For instance, the process of cellular respiration converts glucose and oxygen into energy, carbon dioxide, and water, illustrating the interplay of chemical reactions in living systems. Now, let's step outside the microscopic world and explore the scale of planets and stars. Our home, Earth, has a diameter of about 12,742 kilometers, while the largest planet in our solar system, Jupiter, measures approximately 139,820 kilometers across. Stars, like our Sun, are massive celestial bodies composed primarily of hydrogen and helium. The Sun has a diameter of about 1.4 million kilometers and is located approximately 150 million kilometers from Earth. It is the gravitational anchor of our solar system, influencing the orbits of planets and other celestial objects. The Sun generates energy through nuclear fusion, a process where hydrogen nuclei combine to form helium, releasing vast amounts of energy in the form of light and heat. This process occurs in the Sun's core, where temperatures reach around 15 million degrees Celsius. The solar system itself is vast, extending out to the Kuiper Belt, which contains icy bodies and dwarf planets like Pluto. The distance from the Sun to Pluto is about 5.9 billion kilometers, illustrating the immense scale of our solar system. Beyond the Kuiper Belt lies the Oort cloud, a hypothetical region filled with icy objects that marks the outer boundary of our solar system, potentially extending up to 100,000 astronomical units from the Sun. This region is thought to be the source of long-period comets that enter the inner solar system. Now let's venture beyond our solar system to explore stars and galaxies. Our Milky Way galaxy is a barred spiral galaxy containing an estimated 100 to 400 billion stars, including our Sun. The Milky Way spans about 100,000 light-years in diameter. To put this in perspective, 1 light-year is approximately 9.46 trillion kilometers. This means that light from the farthest reaches of our galaxy takes thousands of years to reach us. Galaxies are not isolated. They exist in groups known as galaxy clusters. The Milky Way is part of the Local Group, which contains over 50 galaxies, including the Andromeda Galaxy, our nearest spiral neighbor.